Assalamu alaikum, how are you everyone? I'm Jan Ahmed Sadiq, and today we are going to discuss about the introduction of chemistry. So already we know that chemistry is a branch of science, right? And also it's kind of how to identify the compounds, elements, and others that's relating to elements of the periodic table. Okay. So right now here, introduction of chemistry. First of all, what the meaning of chemistry and what the branches of chemistry and what chemistry are like important, why chemistry are important for the student life or for life itself. So first of all, here right now, chemistry is the study of composition or the proposition of compounds or elements, and also is the study of like living things, not exactly living things, but actually the chemicals that's inside the living things. Okay, so that was the meaning of chemistry. The second thing, which is branches of chemistry. Branches of chemistry can be classified into many, but we can specify just five or four of them. Like for example, we have organic chemistry, inorganic chemistry, and also analytic chemistry, and physical chemistry. Of course, there is others which is biochemistry, and there is geochemistry and others that's related to chemistry, because chemistry can be identified in every field of science, because without medicals or like without medicines or chemicals, how could this science or this field be identified? So also physics are using chemistry on it by using atoms, molecules, and others, right? So the process of chemistry can be classified into five or four. We can say chemistry. Okay. First of all, organic chemistry, and then inorganic chemistry, and then biochemistry, and physical chemistry, and then analytical chemistry. Right? So first of all, organic chemistry is a study of compounds, okay? Anything that's related to compounds, I mean carbons and hydrogen, okay? That means the compounds that's having carbon, hydrogen are under the field of organic chemistry. In organic chemistry, that means any compound that doesn't have carbon. That means it's the opposite of organic chemistry. Okay, then biochemistry meaning life and chemistry. Bio is the study of life or living things. That means biochemistry is just a studying of living chemistry by using chemicals or chemistry inside it. And then physical chemistry, which is the study of physical, which is physics, and chemistry. That means the combining of two fields together, which is physics and chemistry. It will be physical chemistry together. Okay, now analytical chemistry meaning that is the study of the quantity or the quality of the compounds. This is also another field of chemistry. Of course, there's many of chemistry fields, but just it's like I think five of them. One, two, three, four, five. That is the important or the most important of chemistry. Okay, so right now here, before defining anything, we should define substance or matter. Okay, what is matter? We know that there is three phases of matter. Okay, so matter, there are three phases of matter, right? Which is solid, liquid, and gas. Right? Solid, liquid, and gas. Could you know that there is a difference or a big difference between solid, liquid, and gas? Like for example, right now we have water. We have water, right? It can be in a solid phase, and it can be as a liquid, and it can be as a gas. How? How water or a compound of H2O can be the three. Like for example, when water as ice, when water will be ice, that means it's on the solid form. But when water is normally liquid, okay, that means it's on the liquid form. But when water evaporation, Okay, the bubbles or the vaporization is called what? Gas, right? So that means water can be the three, solid, liquid, and gas, and also other compounds that can be the three. But what are the difference between these three? First of all, solids are having fixed position and have tightly packed of arrangement, okay? First of all, it's tightly packed. It can be drawn as like this one. It's tightly packed, there is no spaces between them. That means the particles are in fixed position and arrangement, it will be in order. Okay? So this is what? This is solid. That means the particles are in fixed position. And it's tightly packed in orderly arrangement. Arrangement of particles. Right? For liquid, it will be different because the particles will have like less tightly packed. That means it will not be in fixed position. It will be in free position. It will be like in free movement, but still it's not that complete freedom. That means it can be like this. There is like small space between the particles. Right? So that means it will be less fixed position. That means some are having free and it's not tightly packed, less tightly packed. Right? For gas, it's completely freedom movement. Also, it doesn't have tightly packed. It's just in disorder. Okay, so it can be like this. Yep, like this. The particles are going here and there. Just they are playing. That means it's completely free, completely free of movement, and their arrangement are in disorder. Also here they are in disorder, but like less. They are less disorder. Here are they are completely disorder. Okay, so that was for solid, liquid, and gas. Okay, so what about substance? We know that substance can be classified into two. Substance actually is the same as matter, but we are familiar with substance always because we are using in chemistry always the word of substance. Okay, so let's first of all write the classification of substance and then the classification of its classification. Meaning that we have substance here, right? And substance can be classified into two, which is pure substance and mixture. Pure substance, pure substances and mixtures. Okay, so right now here also pure substance can be classified into two, which is elements and compounds. Elements and compounds. And for mixtures also it can be classified into two, which is homogeneous and heterogeneous. Homogeneous and heterogeneous. Okay. First of all, pure substances can be classified into two, which is elements and compounds. Why? Because we know that elements are just meaning of not compounds, but it is in the periodic table. They are pure elements, just pure substances. That means its elements and compounds can be classified into two, which means we need to see an example of gold. Can we say that gold is a mixture or a pure substance? Of course, it will be a pure substance, right? Because it will be under elements, because it's there in the periodic table. So elements here right now are classified as like elements that cannot be broken into two. Okay, but for compounds it can be broken into two. But compounds, it's like mixing, not mixing, but like combining of two elements chemically. Okay, together. That means, for example, H2O. H2O, H is hydrogen, O is oxygen, and both of them are combined together by chemicals. That means it's a compound, right? H2O or water is a compound. Elements are just like elements alone. Like for example, here what do we have? Ag, Au, Ge, Ar, and Kr. Okay? Right now, what do we have? Silver, gold, germanium, argon, and krypton. Right? So all of these are examples of elements. But for compounds, we can say that H2O, NaCl, C12H22O11 are examples of compounds, which is water, sodium chloride, okay, sodium chloride, and sugar, right? Or we can say, yes, it's sugar. C12H22O11, and it can be, it's the combining of fructose and glucose together. So this is what pure substance. But for mixture, it's also homogeneous and heterogeneous. So homogeneous here can be classified into homogeneous and heterogeneous. Another name for homogeneous is solution. So whenever the question is asked, what is the solution of this, not like solution, meaning of identify whether this compound, okay, it's a solution, or this mixture, it is a solution or a heterogeneous. Meaning of solution is homogeneous, okay? So what's the difference between homogeneous and heterogeneous? Maybe the first thing that you will notice that the spelling is different. Homogeneous and heterogeneous, the spelling is different. Not only just, but also because homogeneous, it's a mixture, but you can see that it's mixed of anything. It's just like completely one type of mixture, right? It's only one type of compound. You can't see what it's mixed inside. And heterogeneous, it's the difference. That means you can see the mixtures that inside it. You can see each type of um, compound or the mixture that inside it. That means homogeneous and heterogeneous are different from each other. Like for example, homogeneous, what we can say, example for homogeneous, like water also. Water, like when you have a water, you can see what is inside, right? Water is just colorless, right? So it's already one type of mixture, and you can see whenever it is mixed of something or not. But if you mix sand with water, here what it will be? It will be heterogeneous, right? Because you can see that sand is mixed with water inside it. That is the meaning of homogeneous and heterogeneous. Okay? So that was about substance, about mixtures, homogeneous, heterogeneous, and four substances that can be classified into elements, compounds, and others. Another topic that's inside introduction of chemistry is about the separation of compounds or mixtures. As we discussed about pure substance and mixtures, that can be classified also into others, which is mixtures can be classified into heterogeneous and homogeneous. Pure substance can be classified into elements and compounds. Okay, so now you may say that there's like a similar things between compounds and mixture, because compounds it's also a mixture of what, of elements, but for mixtures it's just like a mixture of substances, not about elements or chemically. All right, so that means there's a difference between compounds and mixtures. Okay, so there's also a separation techniques that can be separating compounds and mixture. Like for example, right now here, what do you have for mixture? Separating of mixture. separating techniques in mixture. Like for example, here what do we have? Evaporation, filtration, chromatography, simple distillation, and also it can be decantation. Okay, so first of all, for evaporation, it's used to separate what? It's used to separate soluble solid from liquid. Okay, but for filtration, it's the opposite. Insoluble solid from liquid. For chromatography, it's used to knowing the color or separation of colors. Separating of colors. Simple distillation, it's to know whether it is volatile and non-volatile. Alright, for decantation, it's not the same as filtration, but it's like the insoluble solid are down on the surface of the beaker and liquid just that you are going to take. That means it just knowing the insoluble or separating what's insoluble. Yeah, it will be knowing the insoluble solid and take liquid from the bake. Alright? So right now here what do we have is evaporation. Soluble solid from liquid. When we are saying soluble or insoluble, that means it's dissolved or undissolved. So for soluble, that means it's dissolved. So when it says dissolved solid from liquid, that means already the solid that's inside the liquid are dissolved on it. That means you can't catch that solid. It's already inside the liquid and it's dissolved. So how could you separate this soluble solid from liquid? By using evaporation technique, right? Then filtration, which is insoluble solid from liquid. Filtration also, I think you know the meaning of filtration, the process of filtration, by using filter papers and by using the funnel. What you are going to collect or to use or to get is liquid, just liquid, or we can say a pure liquid without any particles of this solid. So that means it's separating of insoluble solids. That means the solids that you can catch, but by using filtration it's better to make the liquid pure. Okay, so this is what filtration. For chromatography is used to separating of colors, and simple distillation is used to volatile from non-volatile. And simple distillation, decantation, it's like the first process before doing filtration. Like for example, we know that decantation, for example, we have a cafe. Okay, we have a cafe and we want to make us the separation of liquids from this solid. So what we are going to do is just having the liquid. Okay, you are already having the coffee, so we are putting on a cup the solids, or we can say the insoluble solids, are down of this coffee, right, or of this cup. That means you are just taking the water without what? Without the solid or without the insoluble solid. So this is decantation. And I think I make a video about decantation, the process of decantation, how it's going to be. But the process of filtration I didn't do, but I discussed about filtration there. So that was about what? About the separation techniques of mixtures. Okay, what about compounds? By compounds, it will be using, like, for example, separation of compounds. For water, it can be electrolysis. Electrolysis, that means the use of electricity can separate water. That means it can be separate water into hydrogen and oxygen. This is what a separating techniques for compounds. Okay, so that was about not actually introduction of chemistry, but like the basics of chemistry. Right now, there's another thing that we need to discuss about, which is how chemistry is important in the student life or in life in general. Okay, so I think you should be having rest from all of these basics and know the exact meaning of chemistry to your concept. Okay, so first of all, that chemistry, whenever you are walking in everywhere, you will find chemistry. Not the exact meaning of chemistry that having chemicals and doing chemicals and also like doing compounds by using elements and wearing the gloves and mask and doing all of this. No, it's not just this. Chemistry here is looking like practical, but chemistry in life it's looking like a philosophy, a big philosophy. For example, whenever you are going into anywhere, like for example, mall, park, or anywhere, you will find chemistry. For example, when you went for a park, you will see that there is sands, right? Sands and others, like also water, sands and others. You will see here it's what? It's a chemistry. It's kind of chemistry. Chemistry meaning like it's not just about chemicals and separating of chemicals, compounds, and elements. No, it's only about how could you understand the elements and the compounds that inside the life. Like for example, when you wake up from your bed, what you are going to do at first, you will take shower first, and this shower is including what? Water. Water is kind of chemistry, right? Because without chemistry, how could we produce water before? How could we know the compound of water, which is H2O, right? And also about brushing your teeth by using a toothpaste, right? It's kind of chemistry that including fluorine, okay, chlorofluorine, and others, right? Also, like for example, when you are eating coffee or eating others, what kind of chemistry it is? It's the chemistry of like not filtration, kind of that when the coffee is resting for many days, you are going to get what? Biochemistry. You will take that it's kind of biochemistry because you are eating something that can make your organs like working by using this food, right? Which is biochemistry. By inciting or by entering what? The chemicals into your body, the body or the organs, it will work. That means it's kind of biochemistry, right? So others also using chemistry, like for example, transportations. It's a kind of physical chemistry, right? Because without chemistry or without the for example, benzene, petroleum, and others that are used by cars or transportations, how could you like go to your job or go to school or go to anywhere that you want by using chemistry, by using not just chemistry. The meaning of chemistry, maybe you will say that, oh, it's kind of science and I cannot understand it. No, it's not that much of or like it's not that much of complex. It's something of just understanding the life. Understanding the life meaning that you understand chemistry. It's not part of philosophy, but it's like just understanding. Like for example, Aristotle, it's a philosopher, right? He is a Greek philosopher, but he used what? He used science. He used science to advise this kind of philosophy. That means, like for example, he used metaphysics. Metaphysics is what? It's coming about reality. And reality including what? Including chemistry, including physics, including other science that he used. So that's why chemistry is one of our life, it's part of our life. And also like for example also without compound, without carbon, how could we live? We are breathing oxygen, and we are inhaling what? We are like taking out carbon dioxide, and this carbon dioxide, who are the things that are taking it? Plants, right? Because plants are taking carbon dioxide, of course, by also taking sunlight and taking water. Then they will produce oxygen for us to live, to breathe. So this is part of chemistry. So chemistry as a life is very important, and chemistry as a student also very important, and more than anyone. Why? Because chemistry as a student is just to understand why these chemists, which are like the people who are studying chemistry, are important in our life to produce medicines for us if we were sick. Who are going to give us the medicines, or who will produce the solution for us or the medicines for us? If there were no medicine in life, you will think that the human people or the human race will be extinct, right? Without medicines. The solution for cancer, how could it be identified? Not by just biologists, but also by using chemists people, because they are the one who is what? Who is producing medicals or medicines for us. So this is what this kind of chemistry. Chemistry is one part. The things that I'm wearing right now, right? My scarf, my abaya, all of these are what? It's also kind of chemistry, because the quantity or the quality, it's by using chemistry in everything in our life having particles, right? So this particle is kind of what? It's not kind of chemistry. Particles, it's about everything. Anything in front of you or behind you is having particles, right? So that's why solid, liquid, and gas, simple things. Maybe you will see solid, liquid, and gas in everywhere, right? But this also kind of chemistry. Ice that you are eating it or drinking with water, what you will think that it's just for drinking because you are thirsty. Not only that, because your organs need that. Your organs need H2O. Your organs need what? Need the compound of water to live, right? So needing of chemicals that can recycling everything again and again. It's kind of chemistry. That means chemistry was here before anyone. That means chemistry was here on earth before people, before the human being, because it was already there in the trees, in the plants, in the animals. This is kind of chemistry. Alright, so that was about the introduction of chemistry. There's something thing also that I want to discuss about, which is the significant measurements or the scientific measurements. So first of all, we know that when our mothers give us born, okay, give us birth, what was the first thing that doctors are doing for babies or for the born babies? What they are doing first? They are just calculating their weight, and also knowing his or her length, and also knows other identities that's related to that baby, right? So meaning that the scientific measurements, whenever you are like in anywhere, there is a measurement scientifics, right? Like for example, when you already have birth of baby, or like means when your mother give you birth, directly the first thing that doctors will do on you is just see your weight, how kilometers, I mean how kilogram you are, and also how length you are, right? How centimeter you are. Actually centimeter, because for me it was centimeter. So anyway, it was, but it was about the measurement of significant, or I mean scientific measurements. Okay, for significant measurements it's like about zeros, kind of zeros. We know that the rules of zeros are just on computers, because we know that the codings are always by 100010001000, just depending on two things, which is 1 and 0, right? Two numbers just. But for scientific measurement, or we can say for significant measurements, it's just for what? It's just for numbers without zeros. But if it was like for example 10001, here we can say that how many significant measurements that we have. We have 1 2 3 4 5. We have 5. Okay, so significant measurement or scientific, we can say SF. Okay, So that means we have 5 right now. Why? Because we have 1, 2, 3, 4, and 5. What about others? Like for example, 0.0001. Here, what we are going to say that we are just having one significant measurement, one. Okay? For others, like for example, 2,000. It can be two answers, okay? It can be in two ways, which is 2, 1, 2, 3, 4. That means 4 significant, okay? And also we can say that 2.0 times 10 the power of, okay, 1, 2, 3, 4. Already we have 1. That means 2 also, or we can say just 2. That means 2 to the power of 3. I mean 2 times 10 to the power of 3. 2 times 10 to the power of 3. That means just one significant. Alright? So there's also another rules, which is 10001, and whenever there's non-zeros, okay, non-zeros, and inside there's so many zeros, they will be included of significant figures. But if there was not, like for example here, directly starting by 0, 0.0001, it will be just one significant, okay? But for having just non-zero at the beginning and then after it we have many zeros, it will be including as significant figures. Okay, so significant figures are what? Are by using numbers, or by using these numbers that can be measured, your measuring your what? Your length, your kilogram, your weight, your others. And the most scientific measurements, that's the major, is mass, length, right? And others, that's including significant measurements or scientific measurements. Okay, so our scientific measurements is like, we can say scientific measurements is about measurements that are calculating inside science or inside the science way. But actually, this one are also using by engineering, right? Not just in scientific way, but also by using engineering, because they are measuring what? They are measuring everything to be in a precise and concise way by using significant figures. Okay, so that was everything about introduction of chemistry, and I hope that in the next part we'll do more interesting videos and topics that's related to chemistry. So have a nice time and goodbye.